Hey guys, where we left off yesterday was you being introduced to our next unit through the Brain Pop video. Before we even continue, do remember that if you're ever absent a certain day, meaning like you were sick and you couldn't do anything at home, make sure you go and complete the day you were absent. So, like if you missed yesterday, you need to go and complete everything there first, and then you can move on to today. Well, anyways, you guys learned about plate tectonics, kind of what it means, the backstory to it. And then I did tell you that in science, we focus on that these continents are all sitting on plates. And these plates are constantly moving, they're just very slow, and we don't really feel that at all. But things happen where these plates meet each other, kind of like where they connect like pieces of a puzzle in a way, and things happen. Certain geological events will happen. Where they meet is called plate boundaries. So, like the areas in red where these two plates meet is a plate boundary. Now, we did talk about, I mentioned that there's continental crust that's all on land, and then oceanic crust is all like the bottom of the ocean sea. So, there's going to be three types of plate boundaries, and the three types are right here. The first type is a convergent boundary. This is when two of those areas in red, they're going to collide with each other, like they're running into each other. It's almost similar to when, like a car accident, when two cars hit each other and they kind of buckle up, um, and just kind of like pile up on each other in a way. That's kind of what happens there. Certain mountain ranges can be formed here. Um, Divergent boundaries. This is when they divide or they move apart. So you have an example here with arrows moving apart. What's going to happen here is more so going to be something called a Rift Valley and a mid-ocean ridge, and I'll show you pictures of those. The last one is when they slide past each other in different directions, so right here. And what's going to happen there is earthquakes will occur. So moving forward, we're going to go over those three now, okay, more in depth. We're going to start with the divergent ones when they spread apart. So it's like this picture in the corner. So they're going to spread apart, and believe it or not, the reason they spread apart is because magma from the mantle is pushing into those two plates. So these plates are spreading apart from each other, and this magma is coming up, and it essentially creates new crust. Underwater, this will happen too, and those two crusts are being pushed apart, and new crust will form in between here. I think I have the picture right here. So, this one is when if I go back to that slideshow, this one is when it happens all underwater. What's going to result is a mid-ocean ridge. It's almost like an underwater mountain range in a way. As you can see in this picture, the divers swimming through a mid-ocean ridge. You can see that new crust came up from the mantle and pushed apart these two crusts and formed new crust down here. So yeah, they're swimming in between there. So that's when it's underwater. Right here is a rift valley, and this rift valley is, for example, this is part of Kenya, and this is part of Africa in a way. And you might have heard in the news that Africa is splitting in two, and oops, didn't mean to click on it. And it is splitting in two for that very reason. Magma comes up and splits apart those crusts, and new crust forms in between. So that just gives you an idea. If we have time, I might go back and talk about some of that with you. But that's pretty much a divergent boundary. New crust is created and they spread apart. Transform boundaries. This is the easiest one to remember. It's the picture here where they slide past each other and they kind of rip into each other. Earthquakes will form here. And just as it says in this slideshow, there's a really famous fault line, and it's the San Andreas fault line in California. And it does look like this. There was a big earthquake. I forget what year it was, but California is very prone to earthquakes. They build their buildings to withstand a lot of them. But I saw in a news story that, what was it, maybe a couple years ago or so, that the San Andreas Fault Line, if you know, like one of those wind up toys where you wind it up, and as you wind it up and it gets harder, that resistance gets very strong and it's hard to wind it up towards the end, and then you let it go and it just goes crazy, that toy. Similar to the San Andreas Fault Line, the scientists have said that it's like a ticking time bomb, if you will. So it's that same, these two plates are like ripping into each other. The North American and Pacific plates are ripping into each other. And as they rip into each other, um, essentially that resistance is building up. So just like that toy, when you let it go, it goes crazy. At some point, that resistance builds up so much that no, science isn't like a predictive study. It's more so of when this earthquake will occur from the San Andreas Fault. They say it could be tomorrow or years from now. So it's just a matter of when it actually does happen. But that just kind of gives you a backstory to the San Andreas Fault Line. Plate boundaries with regards to convergent. This one's going to be the hardest one to remember because three things can happen here. That's why we saved it for last. This is when these two plates will meet and collide with each other, just like the buckling up of the car crash I told you guys about. So when two plates collide, but they're both on land, meaning nothing's underwater, you're going to get mountains, like folded mountains. If you ever heard of the Himalayas, these mountain ranges, look, you can see the folds in there. This kind of reminds you maybe of maybe some of like sedimentary and some of metamorphic rock, if you will. But you can see in a lot of these ranges those folds in there. So that gives you an idea of that. But that's what happens when both these two plates are on land. When they're both underwater, I'm going to skip to this one. When they're both underwater, they'll collide, and similar to mountains, they'll form like underwater mountains, but they're known as volcanoes. So there's this big hotspot area out in the Pacific Ocean, known as the Ring of Fire. It's a big area for tons of volcanic activity. And the island of Hawaii was also formed this way. So as you know, these volcanoes form underwater, eventually they more and more land is created, and eventually you can have some islands there, such as the island of Hawaii. So that one's probably your easier one to remember, in the fold mountains. So when it's both on land, mountains; when it's both underwater, volcanoes. Now the other one is when you have land and ocean. When those two plates meet each other, things happen. So you can have something known. Let me skip to it. Here we go. This is when you have, they collide, and it's going to be land and water. So what's going to happen is that they collide, but they're not going to buckle up. The reason is because they're different. One's oceanic and one's continental crust. The oceanic one is going to be more dense, meaning it'll sink. So this crust, when they collide, will go underneath the other crust. And when that happens, things can occur. You can have something called a trench, and it happens around here. It's almost like areas where underwater it's really higher than the other side, if you will. You can also have some more on land type volcanoes where the lava could spew into the ocean and make more spread out the land, if that makes sense. So stuff like that can occur. This area, the old crust, is when the oceanic crust goes under and it sinks down. The old crust is essentially destroyed or recycled back into the earth. Before, like other years, I've had kids ask me, so back up, when it goes to here, and this is called sea floor spreading in a divergent boundary when they divide. When new crust is being added to like the seafloor of a mid-ocean ridge or a rift valley, when new crust is being added, is the earth getting bigger? The answer there is no, and the reason is because on the flip side, at a subduction zone, crust is being destroyed or recycled back into the earth. So it's almost like it's recycling itself. I hope that makes sense. It's a good video to maybe go back and rewatch if you need to. Um, but yeah. So those are the 3 types of boundaries. That's what you need to know now. I'm going to put these notes in your agenda for today, and these notes are good to have. I don't think you need to copy them down or anything. What you should do though, maybe is screenshot them and just save it on your desktop, or maybe put it in your drive under like a plate tectonics folder, maybe for science in your drive or something. Kind of create something for you that you can have to easily access if you have to do something later on. But that's it. Please go back to my agenda now and complete the next step.